Here we're going to look at the symmetry of the unit circle and how this can help us find sine, cos and tan values for other angles that aren't in the first quadrant. So what we've considered so far is we need to know our sine, cos, tan values for angles such as 0, pi on 2, but also pi on 6, pi on 4, pi on 3. So if you don't know your sine, cos and tan for these, you need to go back and review that, watch the video. What we're going to look at here is how we use that knowledge to help us find things like sine, cos and tan for angles such as 3 pi on 4, or around here we may have 7 pi on 6, and using the symmetry of the unit circle and relating these angles back to what we call our reference angles in the first quadrant to find sine, cos, tan for these other angles around here. So we're going to work through a couple of examples together. First one is, let's say we're asked what sine 4 pi on 3 is. So firstly we need to work out where is 4 pi on 3 in the unit circle. So we know pi is half of the circle, so pi is around here. So pi on 3 is about here, so that's 1 pi on 3. 2 pi on 3 is going to be over here, that's 2 lots of pi on 3. So if I start here, 1, 2, 3 pi on 3, so 4 pi on 3 is going to be round here somewhere. What we've effectively done is gone another pi on 3 past pi. So this is pi plus pi on 3 is another way of thinking about it. And we're trying to find sine of this angle, and the sine value is, the sine of the angle is the y coordinate of this point here. What we find is if we relate this, if we go up like this, we see that the reference angle for 4 pi on 3 is actually pi on 3. What we've created here is two triangles which are the same, exactly the same, here and here. And we're trying to find what is this value here, sine of 4 pi on 3. Now sine of pi on 3 is up here somewhere, and this distance here and this distance here are exactly the same distance. One is positive and one is negative. So what we've established so far is that sine 4 pi on 3 is the negative of whatever sine of pi on 3 is. Sine of pi on 3 is. So sine of pi on 3, I would draw up a quick triangle if I didn't remember it. 1, 2, root 3, pi on 3. Sine of pi on 3, opposite over hypotenuse. Sine of pi on 3 is root 3 on 2, so that's that there, that's root 3 on 2. So this down here will be the negative of that. So therefore, sine of 4 pi on 3 is negative root 3 on 2. So that's how we use the unit circle, and we use the first quadrant reference angle to work out sine of 4 pi on 3. Let's try another one. Cos of 7 pi on 4. Okay, so firstly again, let's work out where 7 pi on 4 is. Okay, so here's pi, which is the same as 4 pi on 4. So if here's pi on 4 here, a quarter of pi. So 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi, 6 pi, 7 pi on 4. 7 pi on 4. And we're trying to work out the cos of that angle. The cos value is read from the x-axis. So that there is going to be cos of 7 pi on 4. Again, what we've effectively done is, it's like going all the way around to 2 pi and then minusing pi on 4. So this is the same as 2 pi minus pi on 4. If I draw a similar angle in the positive direction, I end up back here, and then because I've created now these two triangles which are going to be congruent, exactly the same triangle, what that means is that cos of pi on 4 will also hit this point on the x-axis as the same point as cos of 7 pi on 4. So the unit circle has shown us here that cos of pi on 4, or actually what I should be saying is cos of 7 pi on 4 is the same as cos of pi on 4. They're the same value. So therefore, if I can work out what cos of pi on 4 is, and I would draw up again a quick triangle, 1, 1, root 2 pi and 4. Cos of pi and 4, adjacent over hypotenuse, 1 over root 2, or root 2 and 2. Therefore, cos of 7 pi and 4 is root 2 and 2. It's exactly the same as pi and 4. My last example is tan of 5 pi on 6. Okay, so again, let's work out where 5 pi on 6 lives. Here's pi, which is the same as 6 pi on 6. 5 pi on 6 is going to be 1 pi on 6 less than that. So 5 pi on 6 is going to be here. It's the same as pi minus pi on 6. And the tan of this, so to work out the tan of 5 pi on 6, I will draw a straight line from the angle down through the origin, continue down, down, down until I hit the tangent line, and then go across. And this value here is tan of 5 pi on 6. Now the reference angle in this case will be pi on 6 itself. If I was to work out tan of, if we call this here pi on 6, if I was to work out tan of pi on 6, I'd go up, I'd go through the circle to here, and then across. And again, if we look at this here, and this here are exactly the same triangle. So what we found is tan 5 pi on 6 is down here, it's a negative value. Tan of pi on 6 is up here, it's a positive value. And they are equally sized. That distance and that distance are the same, but one is positive and one is negative. So tan of 5 pi on 6 is equal to the negative of tan of pi on 6. So to work out tan of pi on 6, quickly draw up my triangle, 1, 2, root 3. Oh, sorry, that's pi on 6 there, that's pi on 3 here. So tan of pi on 6, opposite over adjacent, negative of 1 on root 3, or negative root 3 on 3 if we choose to rationalise the denominator. So there's an example of sine, cos and tan of different angles around the unit circle. What we basically see is that here are our three reference angles, and they all match up with these angles I've put, and I've colour-coded this. So if we think about pi on 4 here, sine of pi on 4 would be there. That would be the same as sine of 3 pi on 4. These angles here, sine of 5 pi on 4 and sine of 7 pi on 4, they would be the same value. They would be the negative of sine of pi on 4 and sine of 3 pi on 4. So, and then if we think about the cos values, here's cos pi on 4, here's cos 7 pi on 4, they're the same. Here's cos 3 pi on 4, here's cos 5 pi on 4, and they are the negatives of cos of pi on 4. So, and then if I look at pi on 3, here's sine pi on 3, here's sine 2 pi on 3, here's sine 4 pi on 3, here's sine 5 pi on 3. So down here sine is negative, and so sine 5 pi on 3 is the negative of sine of pi on 3. Cos pi on 3 here, cos 5 pi on 3, cos 2 pi on 3, and cos 4 pi on 3, and they are the negatives of cos of pi on 3. And then my last one, pi on 6. So let's just get this this pen right. So here we go. Here's sine of pi on 6 is here, and sine of 5 pi on 6 is the same thing. Here's sine of 7 pi on 6, it's negative, and sine of 11 pi on 6, also negative, but we'll relate back to pi on 6, and then the cos values again. And the same would happen if I add in a tangent line. And again, let's make that a different colour. So if I put a tangent line that runs, we imagine it going through here, and I wanted to work out, let's say, tan of pi on 4, it would be through up here and to there, and that would be the same as here, 5 pi on 4, so tan 5 pi on 4 would be the same as tan of pi on 4. So any of these angles here, you can always work out sine, cos, tan of them just by relating them back to a first quadrant angle. Now the last example we will look at is a couple like this. So let's say we've got sine A is 0.8 and we want to know what sine of pi plus A is. So the way I would do it would be I'd consider where that angle A might be. So if it's got a sine value of 0.8, it's a positive sine value. So if I think about where sine can be positive, it's in either quadrant 1 or quadrant 2. So I might decide to put angle A about here. So there's A and it's got a sine value of about 0.8. So here's A here. Pi plus A. Okay, pi plus A is going to be, well, here's pi around here. And if I add another pi to A, sorry, if I add another A on, pi plus A is going to be around right there. And here's its sine value. It's over here. And it's going to be, these two are going to be the same size. And it's just going to be the negative of sine of A. So sine of pi plus A will be negative 0.8. And now if I look at cos of B is negative 0.3. So where is B going to be? It's got a negative cos value, which means it may be in the second quadrant or the third quadrant. That's where cos values are negative. So let's say B is about here. So that's the size of B there. And it's got a cos value of negative 0.3. Pi minus B, let me do this in a different color to show this. We'll do this in blue. So here's pi around here. If I go pi and then minus B, now B is clearly between pi on 2 and pi. So pi minus B is going to be like going round to pi and then back by B. So if that's B again there, here's pi minus B. That's where the actual angle is. And cos of it's here. And this is the same as this, but one is positive and one is negative. So cos of pi minus B would be 0.3. So understanding a unit circle, really useful for working out your sine, cos and tan values for a whole range of angles. Particularly though, you'd need to be comfortable with this idea of relating second, third and fourth quadrant angles back to a first quadrant angle.